Hi, we go on with our movie about ViewPAC programming in trace mode using the Uniform Project Development Technology. This is the episode 2. Our task is to develop an embedded HMI for the screen panel of the ViewPAC controller. On the panel, we will visualize our ViewPAC I/O real-time status. For example, let's show the first analog input state for the model i8017H, all digital outputs for the model i8054, and let's make a tool for the output IOS control. For such purpose, we create a new component, panel, in the group channels. Let's open this component for editing by double-clicking. Let's change the screen resolution. That will also make invisible the main menu and the status bar of the Windows CE. Let's define arguments list for our screen panel. It can be done by drag and dropping the channel WinCon AI0 from the group 8017H. The channel WinCon DO8 from this group, and for this argument let's change data type to real. Then we must create a new argument manually with IO type in/out, data type boolean. For programs control, and change attribute to status. Now we begin to draw embedded HMI for controller. Let's insert trace mode logo in the left upper corner. For that, we should choose layer resources and make the group images. After that, we will make component image library and open it for editing by double-clicking. Using the icon import, insert one of the trace mode logos to our library. For example, this one. After this operation, we return to trace mode graphic editor. Using the resources icon, we will go to image library and drag and drop trace mode logo to the left upper corner. OK. Let's type the title using the graphic element text. Now, let's draw a tank with the help volumetric graphic element tank. Pipe. Let's change weight and insert the valve. Let's define get type and let's change color. Let's show the level of filling for the tank by means of graphic element text. Then let's link internal attribute binding with the first argument from our list. Let's now show the state of digital outputs. Let's select trend and create a curve with the help drag and drop. From the second argument. Select tab curves, change color, thickness, and set maximum value 255. And the last, disable interpolation. In order to control the logical program execution in real-time mode, we place the button XOR on the panel. Let's set value equal to 1 and link the third argument from the list to the internal attribute binding. Finally, we type on/off and bind it to the internal attribute text. OK. Then we should save our project on disk and compile it for real-time monitor too. In order to upload our project to controller, let's highlight embedded ATM node in project tree and open the context menu. Select Download to controller. Press button Download and wait for OK. And after that, press button Restart. Now our controller has an HMI and we can see all analog and digital signals in real-time mode. We can also switch them on/off manually and automatically with our program. Turn off our program. And then start it again. OK. Now let's add another component to our project, an HMI on PC. We'll do it in no time. With this mode, it's very easy. Select the system layer and make a new node, RTM. Open it for editing and set networking for the system adapter . Let's delete an empty group channels and drag and drop groups 8017H and 8054 from embedded to ATM node. Analog and digital signals from controller via network. By the way, the ATM can also perform data logging, alarming, visualization, post-processing and automatic control. Let's display on the ATM screen of our PC the same signals as we have shown before on the embedded RTM panel. For that, let's select the RTM root group and create a new component screen. Open it for editing and drag and drop to arguments list channels from this group, the first channel, from this group, the second. Change data type to real. First analog input from model 8017H, this digital output from node embedded RTM from model 8054. Well, let's place this mode logo in the left upper corner. Type the title, Mode HMI on PC. We use the same volumetric graphic elements as we have used in ViewPAC to draw a tank. Pipe, change weight, valve with the same type gear. Let's show the level of filling for the tank by means of graphic element text. Attribute text, indication type value, binding with the first argument from list. Float format. Well, let's now show the state of digital outputs. Let's select trend. And let's create a curve by drag and dropping it to the second argument from list. Select tab curves, change color, thickness, set maximum value up to 255 and disable interpolation. Now we should save our project on disk and compile it for the real-time monitor. Let's highlight RTM node in project tree and launch Profiler. Then start it too. Well, this is value from the first analog input. This is digital output. So, now we can see that data exchange between controller and PC is established, and we can see the same data on controller's embedded panel and on PC. Finish. We have developed a distributed control system using the Mode uniform project technology nearly 25 minutes. Thanks for your attention and bye.